Okay, guys, we're recording. Thank you. All right. So solving inequalities. We're almost done with this unit. So, guys, thanks. But hold off on the football banter. Thank you, appreciate it. Okay. So, how do you solve inequalities? It's just gonna be very similar to equations, just a slight twist at the end, and you'll see that twist in just a little bit. But what strategy should I use? When you look at that question there, similar to solving equations. It's not going to be that much different. How the solution is correct? You can plug it back into the inequality. How can we show we found all of the solutions? Probably graphing the inequality could probably be the best way to do that. So those are some thoughts that just popped in my head of what we can do for these problems. So here we have two equations, right? We have y equals 2x squared plus 5x minus 3, y equals x squared plus 4x plus 3. What type of graphs are these? Both of these equations are parabolas. Totally, right. So can you tell which graph is which? Well, let's take a look. I think there's one obvious way you could tell. What do you think the y-intercept is for the first equation? So the one that's 2x squared. It's -3, right? The y-intercept here is -3. How about for the second equation? Well, that +3, perfect. So that's a quick and easy way to distinguish graphs. So it's pretty clear that the orange graph, that's orange for me, it's probably black and white for you guys, but it's pretty clear the orange graph is going to be y equal, actually I'll color code. So that'll be y equals x squared plus 4x plus 3. I think that's pretty obvious. And looks like it's dark blue or purple would be the one at 2x squared. Okay, so that's pretty obvious. So now, and again, you guys don't see an orange, unfortunately, but for what x is the orange graph higher than the purple graph? So in my case, just look at my screen, right? Because I have colors. I should have actually done. Actually, did you guys have color copies? Oh, I'm sorry. I should have done that for you guys. Next time. And actually, it's purple, not blue. Okay, so anyway, let's take a look where they touch. I think that's going to be very important. Where are they touching? Perfect. We'll just use the x values. Well, yeah, let's just talk about the x values first. X equals -3 and x equals 2. So it's pretty clear between those two x values, the orange curve is above the purple curve, right? So y equals x squared plus 4x plus 3 is above the other equation when this is true. When that's true, when x is between -3 and 2, the orange curve is definitely above the purple curve, right? Or blue curve, whatever you want to call it. Okay, that's important, and here's why that's important. Well, I need a copy for myself. Here we go. Because now we're going to solve the inequality on the next page. So you use the graph to solve it. So here's what we're going to do. This is the purple. And that was the orange. So where, for what, guys, quiet please. What values of x is the purple curve above the orange curve? Well, what was it the other way around? The orange curve was higher than the purple curve. So orange was greater than purple when x is between -3 and 2, right? We said that already. So if the other way around, exactly, thank you, Jack, that's perfect. So the other way around, x is less than -3 or x is greater than 2. So if I go back to the graph again, where is the purple higher than the orange? clearly, let me clear my screen for a moment. Clearly, the purple curve is higher than the orange curve, starting at -3 and going that way, right? The purple's above the orange in that region. We're also the purple higher than the orange. See where they touch at 2? After 2, when you go into the right, the purple's above the orange. So graphically speaking, you can just look at it, right? Just don't overthink it. Just see it like, yeah, totally that curve's above the other one for that X value or that X interval. So let me undo my erasings there. So yeah, that's what happens. Now let's prove it algebraically. Graphically, we see it. Should be very obvious. We'll do more of these so you guys get the hang of it. Algebraic is a little crazy, so bear with me here. It's going to be kind of a new process. I think it's new for everybody. And how the solutions of that be different? I'm not sure what that question means. But let's look at D first. So how do you use algebraic? What you want to do, I'm gonna give you kind of a, I hate saying cookbook recipe, but it's gonna be kind of that way. So what you want to do is the following steps, and then we're gonna follow through on the steps in just a sec. The steps will be collect all terms on one side. Okay. The second step is a factor. The third step, this is gonna be new. It's gonna call the sign chart. What? Yeah, I know. I'll talk about it in just a sec. And the fourth thing would be to state your answer. Okay. I think the first step you guys should be fine. Put all terms on one side. So I'm gonna have 2x squared plus 5x minus 3 greater than or equal to, I'm gonna copy the inequality right now and then do this. I'm going to subtract x squared. I'm going to subtract 4x, and I'm going to subtract 3. Does that make sense what I just did? Boom, boom, boom. Those are all gone, right? So what do you get after you do the subtraction? Yep. Greater than or equal to 0. This is important. We have to get 0 on the other side because it's going to make comparing the x values much easier when it may have 0 on the other side. Now you factor. This is a pretty easy one to factor. How do you factor that? XX, and how do you break apart -6 to get what we want? What does that say? Say it. Yep. 2 will be negative, 3 will be positive. Great. Okay. This is a new thing, the sign chart. What you want to do when you make the sign chart, identify the x-intercepts and label them on the number line. So what are the x-intercepts here? Perfect, good. Then what you do is you test values in each interval to see if the factored expression is positive or negative. Hope you guys can read that. I'll repeat it. There's a lot. This is really the whole essence of the last thing I just wrote. So you got to make sure to take notes carefully. I record the notes, so you guys should audit your notes, make sure notes are accurate. Try to do it during break if you can. That might be a good thing to do. Because I have all the videos of Schoology. Test values in each interval. How many intervals did I make here after I partitioned it? 2. Actually, more than 2. 1, 2, 3.
I don't get the sign chart thing.
Just wait till I finish. Yeah, it'll make sense. Just wait. So what I did first, I found the x-intercepts. I know you guys can do that, right? That makes sense. So -3 and 2. So I made 2 partitions, but it's 3 intervals: the far right, the middle, and the far left. So there's 3 regions. Those where x is bigger than 2, those when x is between -3 and 2, and those when x is less than -3. So what you do is you test the values in each interval to see if the factored expression is positive or negative. Let me explain what that means. So let's focus on 2. Give me numbers bigger than 2. 3. Test 3 into the factored expression. If you plug 3 into that, what's 3 plus 3? What's 3 minus 2? What's 6 times y?
6.
So that's positive, right? So I'm gonna put a little plus sign there. Okay, let me actually undo the arrows so it's not as distracting. So I'm gonna put a little plus sign there. Give me a number between -3 and 2.
1.
1, great. You could do 0, whatever you want, right? If you put 1 in, that's 4 times -1. What's 4 times -1?
-4.
So it's negative in that region. That'll be true for anything between -3 and 2. Lastly, -3. Give me a number less than -3.
-4.
-4, great. If I plug in -4, I get -4 plus 2 is -1. What's -4 minus 2?
-6.
What's -1 times -6? So you're going to put a positive sign. Now, this expression has to be greater than or equal to 0. Are positive numbers greater than 0 or are negative numbers less greater than 0? What's greater than 0, positive or negative?
Positive.
Positive. So I want the positive answers, not negative answers. So I'm going to highlight the positive regions here and here. So now I state my answer. My answer is going to be, and we're going to do this again, guys, so you get the hang of it. My answer is going to, oh, geez, let's go back to, yeah, totally. X will be less than -3 or X is greater than 2. Because that guarantees that this expression stays positive. You want this to be positive because you want it to be greater than 0. You want that to be positive. Guaranteed we're positive in those two regions. Not in between. In between, by plugging a value in between, I got a negative outcome, right? That's not good. Negative numbers not 0, but less than 0. So that's how it works. We're gonna do this again. You guys will need some drilling. It's okay if it still seems a little weird. But I'll tell you right now, this is probably the most important skill. When you move on to pre-calculus and calculus students do this every day. Talk to any calculus student, they do sign charts. It's the first time you're seeing it probably. Don't worry, you'll get the hang of it. And there's actually ways we can do it even better. I'm just kind of giving you the fundamentals right now. Before I move forward, questions, please ask if you're stuck. If I need to re-explain, come out through a different angle. Because I might be teaching calculus in a couple of years or pre-calculus, I'll expect you to know this. And if you don't, that's my fault. Then I failed you guys. So you guys really need to make sure we get this. Not today, obviously. It's the first time you've seen it, but ultimately this has to make sense. Oh, let's talk about part E then. Okay, that's fine. If you're still thinking about it, that's fine. Part E, how the solutions of that be different? I'm not sure what that question means. Does it? I don't know if that question is asking us how the solutions that be different. Oh, thank you. Gosh, I'm like a total space cadet. Thank you, Davis. Yes. My bad. We could equal those. Okay. Wow. I totally missed that. Okay. Thank you, Davis. Yeah. Now I'm going to pretend I know what I'm talking about for D period because I. Thanks. Yeah. I should have seen that. My bad. I didn't realize that. Good job, Davis. All right. So in this case, for E, you would say X is less than -3 or X is greater than 2. So no equal sign. So it could equal -3 or 2 for part D, but cannot for E. Okay, there we go. I didn't see that initially. That was incredibly subtle. Oh, thanks.
How is X less than -3?
Oh, that's because of the sign chart when I did the number line and when I tested numbers in each interval. So remember we tested -4 and the expression was positive. And you want to be positive because you want to be bigger than 0. So you have to look at what inequality you got. If it's greater than 0, then you have to guarantee a positive outcome. X bar is less than -3, guarantee that. X is going to also guarantee that, not in between. That's why we focus on the outside, not the insides.
You don't do the inside?
So we did, but it was negative. We want to be positive. Because the expression
number in between numbers negative, that you just don't, right?
It depends on what you're being asked to do. We were being asked to do this, right? X plus 3, X minus 2. So we wanted this to be positive. So I had to see which region gave me a positive result. That's what's happening. Let's move forward. Okay. And then F, what about that? Just the reverse. And the reverse was this. There's just a reverse for that one. Okay, let's try another one. I'll kind of give you guys a little bit of a push here. And then we'll do one more problem, then we're done. Okay. We're doing great here on time. Let's keep moving here. All right, so for 459, same graphs, right? They intersect. We call them the boundary points for the inequality. So where are the boundary points for that? Well, let's factor that, right? Okay, so we want to fact. You had a question, or I thought you had your hand raised. Sorry, the balloon's kind of just throwing me off a little bit. You're good. Okay, so guys, you want to factor. Okay, how do you factor this? X and x, and what's going to go next to the x's? Negative or positive? What do you guys think?
That should be negative 3, right?
What multiplies a negative 10 adds up to negative 3?
Which one is? Oh, sorry, I was looking at the one.
Nope, we're looking at this one now.
Positive.
Good, negative 5 and positive 2, right?
I was looking at
Okay.
plus 5.
So your boundary points, no worries, is x equals 5 or x equals negative 2. Okay. All right, that looks good to me. So what portion of the number line contains solutions for this inequality? So you're going to do a number line. You're going to locate negative 2 and 5. So we're rinse and repeat, right? We're just doing the same thing. How many reasons you need to test? We're going to test all 3. We're going to test all 3. And give me numbers bigger than 5, guys. Give me a number bigger than 5. Between the two.
1.
Less than negative 2. Great. Let's test them out. So we could do,
2.
you know, I told you I could do this better. I think I am. I'm going to make a table. I'm going to put the x values on the left side. I'm going to put the expression on the right side. Just to make our lives easier, right? And then I'll do a third column. What the heck? Plus or minus. Okay? So x is 6, 1, and negative 3.
Why are you doing it like that? Does it matter?
I'm just trying to be organized. That's all.
Oh, okay.
Yeah, that's all. Okay, if I plug in 6. 6 minus 5 times 6 plus 2. What's 6 minus 5 times 6 plus 2?
1.
1 times 8. 8, good. Is that positive or negative? So put a plus sign. Plug in 1. 1 minus 5 times 1 plus 2. Negative 4 times 3. Negative 12. Okay. Negative. Let's plug in negative 3. What do you get when you plug in negative 3? Negative 8 times negative 1, which is, what do you get when you plug in negative 3, guys? Negative 8 times negative 1. Positive 8. Yep. Okay. We want positive since x minus 5 times x plus 2 is greater than or equal to 0. So let me get a little highlighter here. We want positive. So what are you going to say the answer is then? Oh, I don't like that. What do you say the answer is, guys? Yep. So x is, and there's an equal sign, right? Is there an equal sign? Yes. X is less than or equal to negative 2, or x is greater than or equal to 5. And you have to say or, because you can't simultaneously be less than 2 or greater than 5, right? Yeah. Now, if it was less than, then you give this in between, because then you want negative if it was less than. One thing to keep in mind too, this might be a little too much to talk about now, but the signs alternate, right? That will not always be true. For now, that is true. There's a reason why these signs alternate, and that's because these are linear expressions. When you start throwing like an exponent here, all bets are off. Things get a little crazy. We're not ready for that yet. We'll get there. But for now, we'll keep things simple. Just a quadratic. You got 2 linear expressions. The signs will alternate. You could probably assume that for now. not for all cases though. So for now, I want you testing all three just to be on the safe side. Okay, questions? Did that help seeing a second time? A little bit, yes,
How do you
no?
write the
Answer?
answer? Yeah.
Right there in black. As an inequality. Because it's a range of values that makes it true. Any x value less than -2 or any x value greater than 5 makes that true.
So how come are you but it's also
What was that?
in negative 3 makes it positive, but also the 5. So why is x greater than?
X is less than -2 because we're anything less than here makes that work. Because I tested a number less than -2 and it worked. I tested a number bigger than 5 and it works. I tested a number bigger and it did not work.
Oh, so anything.
So basically, you have three groups. Which of those three groups is going to make that happen? Two of those three groups make it happen. So positive in this particular case, positives happen.
And you only write the positive.
If it's greater than.
What do you wait? You write only the equations that are.
The inequalities that are positive.
Yeah.
Which is those two.
Well, I still don't understand how x is greater than or equal to 5.
Okay, because I tested this interval, right? So any x value bigger than 5 makes that true. Like if I put in 5.01,
Oh,
5.01 makes that true.
wait.
Think about it. What's 5.01 minus 5? That's positive. What's 5.1 plus 2? Positive. Both by two positives, positive. Positive is greater than 0. Let's work when we do the homework. I'll sit down next. Yeah.
I think there's another way I could approach it with you that might help a little bit better. Okay. All right, 461, guys. One last one here before we send you guys off to Thanksgiving break. Okay, or you could do homework before break. Okay, guys, quiet down. So solve the following inequality and answer the following questions. Okay. So the first thing I would do is I'd add 2 to both sides. So for absolute value, you want to isolate, guys, quiet please. Isolate the absolute value expression. Okay, so what's the first thing I should do in this isolation part?
Add 2.
Yeah, I think it's rough. And how about what's the next step? Divide by 4. And what's going to happen is you end up getting 2 inequalities. You get this. And I haven't really talked much about this. Maybe we should have more of a discussion about this. I don't know. I know you guys did absolute value stuff on Monday on the video when I was not here.
So I don't know how you might feel about this, but let's just take a step back and look at that middle step, right? X plus 1 is greater than 2. Well, duh, of course x plus 1 is greater than 2. Like x could be 3, that could work. X could be 10, that could work. X could be 1,000,000, that could work. But
That's not the whole story. Because absolute value. If I plug in 0, does that work? What's 0 plus 1? 1's not greater than 2. That's no good, right? Or over here. But what if I make x plus 1 less than -2? What if x is -10? What's -10 plus 1? -9, right? What's outside -9? 9. Is 9 bigger than 2? Yeah, guys, I need you to focus, please. Thank you. So, yeah, that could work. So x plus 1 could also be less than a negative number. The bottom line is when we have absolute value, it's going to be 2 different stories. The expression greater than that number or the expression less than its negative counterpart. You can memorize, but trust me, you guys will forget in 3 weeks when we have our final exam review. You can just say, yeah, you just flip it and make it negative. But really what's happening, x plus 1 could be larger than that number, or it could be less than the negative counterpart because it still works. So your boundary points, so x is greater than 3, or x is less than -3. So your boundary points, oh, I lied. I meant to say greater than 1, or less than -3. So your boundary points are 1 and -3. Those are your boundary points, 1 and -3. So now I'll draw a number line. Davis, go ahead.
On the number line, why couldn't you just take like label -3, label 1, and just draw an arrow to the right of 1 to the left of 3?
That works too.
Do you have to do like the plus over the 3 areas?
Well, you have to see which one would make sense. I mean, which
Well, if it's saying X is less than -1, can you just say, all right?
Yeah. So in this case we could actually do that. So what I'm gonna do here, I'm gonna put a little hole here and go this way, and a little hole here and go that way.
You don't have to do the plus or whatever.
Not necessarily, because we've actually already solved it now. Because if you think about it, if I plug in numbers bigger than 2, sorry, bigger than 1, 4 times 2 plus 1 minus 2 is greater than 6. That's true. Because 12 minus 2 is definitely bigger than 6. Oh, hold on, Hunter. If I plug in, say, -4, 4 times -4 plus 1 minus 2 is greater than 6. That's true. Because 4 times 3 minus 2 is still the same thing. So in this case, actually, we got direct to the answer. By the way, I solved it. I solved it in this manner, so I got direct to the answer in this case. So I did quite a little differently than the previous problems, but I think this is pretty efficient too, the way I did it. So the bottom line is isolate the absolute value, solve each inequality. That actually is going to be your answer. So your answer is actually this right here.
Is it,
Go ahead.
I don't know if it's greater than or equal to. If it's,
What do you mean by greater than or equal to?
sign, you know,
Oh, I didn't put, there's no equal sign in the problem.
The problem just had greater than symbol.
oh, so we just use that?
It's whatever they give you.
Okay.
Yeah.
So that's,
You go with what you're given. So,
okay.
yeah. All right. Let's wrap this up. We're almost done, guys. Okay, CDE. So you're asked to graph this. Okay, I think you guys can do this graph just fine. All right, so let's find the vertex. Now remember, our answer was this. Hold on one sec here. Okay. Remember, our answer was this: x is less than -3, or x is bigger. That was our answer, right? What's the vertex here, guys? -1. Right. So it's the opposite.
Thing in the middle.
Right. Let's make a nice little table. Let's plug in values close to -1, like say 0 and -2. If I plug in 0, what do you get? 2.
Wait,
If I plug in 0 for x,
oh yeah, oh yeah.
if I plug in -2, what do I get? Hold on a sec. Still get 2, right?
Oh wait, oh yeah, that's right. It's positive.
Okay. So the graph looks like this. Okay. Now, the question was, you want this to be bigger than 6. Actually, let me do my graph a little more neatly. So here's y equals 6. Here is y equals 4 absolute of x plus 1 minus 2. So the question is, highlight the parts of the graph where this is bigger than 6. So where the absolute value is higher than the horizontal line.
So we'll just plug in 6. Oh wait, it's already plugged in.
It's right plugged in. So isn't this portion here above the blue line, right?
Because this portion, the triangle part's below the blue line. Which one's above the blue line? Those arrows, right?
Yeah.
What are the x values for those arrows?
X is
X is, whoa,
greater than -3.
less than -3.
So what? Yeah. You don't want it to less than though.
Okay,
That's a -3, right? When you're to the left of -3, are you less or greater?
Or you less.
Exactly.
and to the right, you're greater than 1. So it's the same exact thing as we got algebraically. If you reverse it, then I'm just going to write the answer. You guys get the point if you reverse it. I don't need to do it over again. You guys get the point. So graphically speaking, greater is above, less is below. That's pretty obvious. So greater is above, less is below. That's how you look at it graphically. That should be very intuitive. Algebraically, we solved it by just isolating x, and we got those answers. So, yeah, there you go. That pretty much covers this lesson. The homework is here. The homework, the first 3 problems, the open stuff. The other 4 problems, I think, are all in review, the whole stuff. So, yeah, so I'll have review that's going on this homework here. And that's that. Okay. So we got about 10 more minutes. Is that right? Yeah. Okay. So you guys, if you guys need to decompress, I totally get it. It's been a long week. But if you want to get head start homework, yeah, go Rob. Yeah. All right, cool. We're all set.